Yes. You're the first to connect. It didn't disconnect, Abi, or just connected immediately.
I just connected immediately.
Okay, that's good. Yeah. Okay. You have to see. You know why you should not be using that method. What you should be using is that new share, and go and click on it, because even now it's still showing on the other one. You have to see yes, new share. So that's the way to do it. You cannot do that unless you have to share it. That's why you have to just do share and go and click on the data editor window.
Can you see?
We can see now.
Yeah, we can see it now. We can see that. Now I want you to the extreme where you see the BMI. Go to the extreme, throw to the extreme end. The end of the data set. And you can delete the BMI, delete it. Although you can even go and calculate another one anyway, no problem. You may not even delete it, don't worry. Now, want to calculate BMI now. You know BMI is the weight over what?
Height square.
Height square, yes, thank you. Don't even delete it, leave it, don't worry. You can just call it BMI 2. So go to transform. Want to calculate BMI from the height. You don't need to enter. So put compute, the first option, compute. Now, you see, move what you want to calculate is BMI. Type BMI there. BMI. You can call it BMI 2. No, you are not moving. That's why I wanted you to delete it, because we have already done BMI for a. That's why I wanted you to delete just BMI 2. BMI, okay. BMI 2. Do not take gap. I don't know why you like this gap. Do not take gap from you. Yeah, yes. Now, you know, BMI is equal to that what you're giving you. Now,
yeah.
Go and click on weight. Move it there. You know, weight over that slash something is yes, division. Yes. Now, click on, don't click on height where yes. Click on this bracket. Click on the bracket. Then move the height inside. Then please on times. This asterisk is the times multiplication asterisk. Then click on height again and move it there. The same. And move it. Yes, you have done it. Weight over height times height. That is BMI. Now, you will see, why did I say you put on click on a bracket? The reason is that the two you are divided by two things. Are you following now? Height and height. If you don't put it there, if you put this in, you now say multiplication. If you now say times height, you are dividing by first height and multiplying by second height. I don't know if you understand me now. So you know, you remember body mass. Everything that bracket now you have. So it means that by the fact for you to put the bracket there, it means that you are dividing by everything inside that bracket. I don't know if you understand now.
Yeah.
So, click OK. Okay. So that is BMI. If you look at it, the same thing with what we have calculated before. That's how to calculate the right. Anything, not only BMI, anything you want to calculate, that's why you compute it. You put the mathematics there.
So even if you want to do your scoring, you can use that.
Our scoring.
You know, like for example, when you try to do like knowledge score, for example.
Yeah, thank you.
And you
that is a very, very valid question. Very valid question. So if you don't mind, because that you are raising is very, very important. If you don't mind, I will even share your work if you don't mind, just for to
No
demonstrate.
problem.
I will
I
just
don't
share on
mind.
the screen. I will show you how we did that one. That one is another question. Thank you for raising that question. Raising that
Okay,
so that I will be able to demonstrate that.
share.
Yes, I will do that. I will share the work. That was another ball game. But the last stage of it is like this. The initial stage of it is different. It's the selection we did yesterday. But before we do that, I want us to we'll do that later. But let's do some other thing.
Okay.
Any question? Any question? Any question in the what we have done now?
I have a question, sir.
Yes, sir.
Yesterday you said that the procedure for cross tap and then this other one of splitting are a little different, that the percentages they bring out will be different from each other.
Yes. I will trash it out also. I think I will do the when I import this lady's work, I will demonstrate myself from my computer, Dr. Ugo's work.
Right.
Because it's a comparative study and the way we did it and the way the result comes out. So thank you for raising it. Those are valid questions. Because some of these things, if you don't see it physically, it will look somehow. But when you see it demonstrated, it's part of what we want to do. Don't worry. We may stay late today. Today is the grand finale. We may stay till this thing. It's just a matter of, I'll just be reducing the volume of the video. You can do a lot of things. I hope nobody will have headache today. Okay. I want us to go and, what do you say?
I have a question too.
Okay.
Raise
your question.
Multiplication for BMI.
Okay, ma'am.
Does it apply for other multiplications you may want also?
Yes, that's asterisk.
No, I mean, if you want to do another multiplication, can you apply this principle too?
Oh, it's not only multiplication we did that. Any calculation it apply. Even you see
That's
that.
what I mean. Okay, sorry. Yeah, any calculation. So it applies for any calculation.
Yes.
Okay, thank you.
Okay, even if you want to calculate the square root of something, just for you to look for the square root and put it.
Okay.
You get it now. So
okay.
But so I think when we will still come, in fact, we are going back there for logarithm. We are going back to that place for logarithm. Or we want to transform. That's the next one we want to do. I don't know. Let's see. Share again, Dr. Shuwade. I will soon leave you. Don't worry. You feel that.
I'm enjoying it.
Okay, that's great.
What should I share this time around?
Share the same thing. I want to see, because I wanted you to share skin lesion, but share the same thing. I want us to explore the age there, if it's normally distributed or not. I want us to explore it. If it's not normally distributed. Yes. So let's remove the splitting. Let's remove the splitting. I just want to explore it generally. Let's remove the splitting. Go to data, yes. Thank God, can you see now? If you want to remove the split, because everything you are doing now, you're doing it separately for the group. So you don't need to move it out. Just click on or analyze all cases. That's all.
Okay.
Analyze all cases and okay. Okay. Yes. So anything we do again now is for all of them. Let's want to explore. Okay, how many things we even explore? Should we explore? Let's explore age and weight. Okay, go to analyze. You see the way we explore now. Go to analyze. We did the exploration yesterday. Go to descriptive statistics. Where are you going? And go to explore. Under the tree, you see explore. Thank you. I think Dr. Bako did it yesterday with that. Okay, move age and weight to that place.
Where? Dependent list.
Dependent list, yes. Thank you. I will reduce the volume. You can use it here, this. Okay, now Go to statistics. Okay, that one there's no problem. Leave that. No, leave that one. Go to plot. Click on histogram also. You know, by default, stem and leaf is there. Dr. Balogun is not around today. Then click on normative with plot with test. Normative plot with step. With test. No. Where did you see that one, sir? Okay. Continue. Then, okay.
Can you see the output?
You have to share with us.
Sure.
You know, your RAM is small. It's not big. So, you have to new share. Here quickly. Why is it taking time?
No, I'm
Okay.
the one that's taking time.
Okay. Now, you can see the mean for age. You know, the age, the weight is down. The age, look at the mean, 40.7. The median, 38. There's a difference. You can see the trim mean. The trim mean is closer to the median because trim mean is 40.42. Is closer to the median than the original mean. I explained the trim mean yesterday. What you do, what do you say?
The median is 38 now.
What do you say?
No, I said the median is 38.
Yes.
It's talking about trimmed
The mean is 40.77.
Yes.
The trim mean is 40.42. Is it not closer? It's closer
That's
to the median.
close to the trimmed mean. I thought it's closer to the trimmed mean than the mean.
Eh?
Is it not closer to the trimmed mean than the mean?
That's what I said now. I said yes, I said the median and the trim mean they are closer than the mean.
Okay.
The logic behind it is to bring the mean close to the median. Because if there's a skewness, that shows that there are some outlier, because it's for the fact that the mean is greater than the median, it means that there is positive outlier. I explained it yesterday. Positive outlier, extreme value that is higher than the rest.
Yes, sir.
Yes, I mean now. If let's say the mean is less than the median, that shows that there's a negative outlier, an outlier that is lower than the rest. I explained it yesterday.
Yes, sir.
I said that for like in this class now, if we say our average age is 38, if somebody bring one old person that is 99 to join, the person will jack up the mean because is adding more to it. It will jack up because the mean is calculated from everything. Median is not calculated for everything, just the middle value. The mean, you have to add everything together and divide by the total number. So anybody that has a same high value will add to the mean because if you add to the total, when you divide it, it jack up the mean. So the mean will be greater than the median. That's a positive skewness, skew to the right. So you now see the graph on the right side, it will be slanting. It will not be symmetrical. But if it is negative outlier, that is a extreme value that is lower. I gave an example. If let's say Dr. Judith now brought the daughter that is 4-year-old to come and join in this training. And when you had the age, because it's contributing small, it will when you now calculate the median in the mean, it will be lower than the median because there's an extreme outlier on the left side, which is negative outlier. So the graph will be flat on the left side, right? That's just it.
Yes.
So when you look at the value of the mean and median, you know if there is positive outlier or negative outlier, that is positive skewness or negative skewness. Outlier is an extreme value that is different from the rest, extremely different from the rest. That's all. So you can see now, this is positive outlier. But what the trim mean does is a 5% trim mean. It removed 5% from the, it didn't use everything to calculate. It removed the extreme 5% from both sides. the lowest 2.5% and highest 2.5%, making 5% when you had it from both sides. It now give you the middle 95 of the data set to calculate the mean. I don't know if you understand me now. So it will now make the mean to be closer to the median. That's 5% mean. Now, you see the confidence interval there. Then where I want us to scroll down. You see the weight also. The weight, wait. I want us to see the weight. Let's see the weight. Scroll. It's okay. The mean weight is 74.67. The median is 75. What can you say about this?
Means that there are no outliers.
Oh,
So what does it mean? Because the mean is different from the median also.
Negative outlier.
Yes, it means there's negative outlier.
Okay.
Does it make sense now? Negative outlier, they said that there are some extremely
Mean is
small,
less than the median.
because the mean is less than the median.
So it's skewed to the left.
It's still to the left. But the skewness is not much because the difference is
outlier or positive outlier.
negative outlier. Negative outlier in the sense that it's a smaller, it's from extremely small value that cause that problem. It's not extremely large. If it's extremely big value that causes it, the mean will be higher than the median. There is a extremely smaller value that causes it, the mean is less than the median. But you can see the difference is not much. So the skewness may not be significant.
Yeah, it's mild.
It's
It's almost yeah, because if you even round it up, okay.
Hello, sir.
Yes, sir.
Sir, please, what's the significance of this 95% confidence interval? When you talk of 95% confidence interval for quantitative variables, what's the significance?
Even qualitative variable has also. Okay. Yes, you are taking us back to, you are forgetting, the one we did in Enugu and fire brigade stuff, all those stuff. And you have not been following our, it's because you were, until I saw you, I opened Telegram.
Yes, sir.
That's why you were able to get information.
Exactly. That's how exactly.
Your number I have is not on WhatsApp. So
exactly.
That was why.
Exactly.
So when I open, I'm trying to transfer all my people to Telegram, because if you remember, some of you that have been on the WhatsApp, what really happened was that one group could not take the WhatsApp. You cannot take more than 256 of two. So you not say I cannot. So I now open a second one. When I open, I now split it. I now send message. Some people say that I should make another person, what do I call it? Administrator also, so that I can increase it. Someone now suggests I should use Telegram, that it take more. And actually, Telegram take about 200,000 people.
Wow.
That's what they say, yes. So I'm trying to, but the only problem is that after initial 200 I put in Telegram, it's not user friendly like WhatsApp. So that's why I've not transferred everybody to Telegram. That was where I was able to locate you on the Telegram. Now, you have not been following our training, the lecture I've been giving.
Yes, sir.
I've given that one, confidence interval. That was under inferential statistics, introduction to inferential statistics. So, but for the benefit of other people, just 1 minute, let me just explain. When you calculate your mean, or whatever you summarize, for qualitative variable, you summarize with percentage, right? For quantitative variable, you quantify with mean and standard deviation or median, whatever, where we are seeing now. Whatever you summarize is what we call statistic. It's for your sample, because you didn't take all the population. It's only the sample you took. But the real thing in the population is called parameter. The mean, like for this one, the mean weight of these people in the real population where they are is parameter. But the mean weight we are getting in our data set is statistic without S. Statistic without S. It only carries S when it is plural. It's different from the subject statistics, which is the subject, right? So the statistics, that's why they say, infant mortality, our statistic, because it's calculated not from all the population, it's calculated from some sample. That's why they are statistics. Anything you do, you summarize from your sample when you do your study, is statistic. It can only be parameter if you can study the whole population. So the parameter is there, the value is there, it's only God that knows it. But you have access to statistics, right? So the statistic is an estimate of the parameter. You are trying to estimate parameter, but you have access to statistics. And that is the realm of inferential. So the process of you calculating your statistic is called inferential statistic. While the process of making judgment, extrapolating from that statistic about the parameter in the population is the inferential statistic. Now, what confidence interval? Confidence interval is a form of inferential, it's an inferential method. It's different from hypothesis testing. You understand that? It's another way of it's another way of inferential statistics. Now, what confidence interval does is that now that I've calculated the weight to be 74.67 mean weight, I know that since I did not take the whole population, that value is not the parameter. You understand? It's not the mean weight in the population. It's just the mean weight in my sample. You understand? It's an estimate. It's called point estimate because it's only one.
Okay. Okay.
Then if I want to know, I want to suggest, I want to guess Showande's age now. I can just say, okay, Showande. I didn't look at that face. I say, oh, maybe Showande should be 30. Now, if Showande is 32, and I say 30, I miss it point blank. You get the picture now?
Yes.
I miss it. But if I give an answer, it should be between 27 and 37, you know, or 34. I will likely capture the age. Who is that? Who is calling? Your mommy, Abi? I will likely capture the age. But if I also say it should be from 25 to 40, I will more likely capture it. Do you get the picture? So confidence interval is a range of value within which you are to certain percentage confident that the real value is within. So this example now, the mean weight is 74.67. I'm 95% confident that in the population, it will be between 73 to 76. Does it make sense?
Okay. Yes, sir. Yes.
I'm 95. I know in the population, I'm 95% sure that in the population, the real mean will be between 73 to 76. That's what this data is saying. So now, that 95%, that another way of saying is that if we do this study 900 times, we'll be able to capture the real weight in 95 of the 100 times. You understand me now? That's what he's saying. So the probability of me capturing the within that range is 95%. Does it make sense now? It's just like if my confidence is 99%, it's higher than 95. That shows that I'm more likely to capture it. It's just like when I gave a range of value for our age, the one that is wide, I say between 25 and 40. You can be sure that I'll be able to get the age there. Rather than say between, it should be between 33 and 34 or 35. I may not meet it. But the worst is when I just say 33. That's the worst because it's a point estimate. I think that one is clear now. That should be a lecture on it. Yes.
In reporting it, for instance, in reporting it in the results. In the results, reporting it in the results, we say 74.67.
Yes.
That's the weight now. kg.
That's a 95% confidence interval, 73.08 to 76.26.
Okay.
That's the way you report it. But most of the time, people don't report it like that. But sometimes you report. Even you can have it for percentage also. Confidence interval of proportion. If something is
of categorical variable,
something is 20%, it can give you 95% confidence that is between 17 to 23. If something is 20%, you can say it's between 16 to 23. 95% confidence. That's the confidence interval of proportion. But the one we usually use more is that when you are calculating maybe t-test or you are looking for difference between mean or proportion. That's confidence interval of difference. Yes, I mean, that's what we have done in our study when you are doing using confidence interval instead of hypothesis p-value. Who is that?
Okay.
So that is just the now any
sorry for taking you back.
Slow down, please, Dr. Showande.
taking us back. Sorry.
Okay. Now, can you see the age? You know, we know that it's skewed to the right. Is that not so? You can see the
Yes,
shape
sir.
now. It's flatter because if it's not skewed, it should be symmetrical. As it goes up, the way it goes up, comes down. But it's flatter coming down. That is skewed to the right. Yeah. But before this picture, I think there is the statistic. Scroll up. I want you all to see the statistic. Komogorov, Smirnov, and Shapirowicz. Look at this statistic. Is the one, all these other pictures you are seeing or looking at it physically, they are subjective. There is some people that put it to test.
I was very ogogoro. I was wondering.
Yes, one lady called it. When I was doing training in one office in a Pathfinder office in Abuja, one lady there said that the thing only what do you call it? There's a name of a place in Abuja that sound like that.
Yeah.
So you now say when I say Komos, I forgot the name. You just call it one name like this. So that just look funny. So if you look at it now, it's the two separate statistics. Look at for the age. What this statistic does is that in the computer, there is a data set in the software that is perfectly normally distributed. So the computer now compare it with your own and see if there's a difference. If there's a difference, that shows that if there's a significant difference, that shows that your own is skewed. I don't know if you understand me now. Your own is skewed. Look at it. There's a significant difference for age now. Shapirowicz, Komogorov is 0.028, which Shapirowicz is 0.013. With both tests, the two tests, there's a significant difference. That shows that it's skewed. That shows that the age is skewed. Now, if you look at weight, it's not significant with both tests. No, we have already said that even that weight, even though it appears to be negatively skewed, there is no significant. The skewness is not much. So let's scroll down now. Because that one is not significant. That should that you can assume that it's normally distributed. Scroll down. Let's see. We soon get weight. I explained this. Who asks question? Who doesn't understand the weight? Is okay. The different understand this stem and leaf. You know, I explained stem and leaf yesterday. Who doesn't understand it? I think everybody was around. It's only Dr. Judith. It's only Dr.
Sorry, Doctor, I wasn't around. I was inevitably absent.
I know. Okay, even Dr. Bello also was not around. Okay, let me explain. You will see. You will see this graph. Yeah, welcome. This histogram and stem and leaf is the same. If you look at the shape, it's the same. It's only that stem and leaf is tilted to the side. It's not sitting on the base like the histogram. Look at the shape. Scroll up small, Doctor. Small, so that I can see the two at the same time.
Mm-hmm.
Can you see? Yeah. You will see that it's the same shape. It's only that the stem and leaf is not sitting on it's just only sitting on the side. It's not sitting on the base. It's just tilted to the side. It's the same shape. So after all, it's the same data set you used to plot it. They are saying the same thing. They are showing the skewness, whether skewness or not. But the stem and leaf give more information than histogram. Because if you publish this data in a journal. Somebody has access. If you publish stem and leaf, somebody will have access to the data set, your data. But they don't have access to the data for histogram. Look at the data. Look at the frequency here. Stem and leaf mean the last digit is the leaf. The first set of digits is the stem. If let's say you are dealing with something that has 3 digits like height, okay, we even do it with height. Because height, is 1.74. So the last digit will be the leaf. The first 2 digits will be the stem. But we are dealing with something which is the age that is 2 digits here. That's why the last digit is the leaf. The first digit is the stem. 1 digit is leaf, 1 digit is the stem. The first digit is the stem, the last one is the leaf. If it is 4 digits, the last digit is the leaf, the first 3 digits will be the step. So if it is 3 digits, the last digit is the first 2 digits is the step. Now let me explain. The frequency mean 16 here now mean the number in that category. So this one means 21, 21, 21, 23, 23, 23, 23, 23, 23, 24, 24, 27, 27, like that. Why are you changing? Doctor? Okay, it's okay.
Please go ahead. Okay. Yeah. So 21.
It's okay, it's okay, it's okay. So what 16 means that there are 16 in this category, 16 people. And that the value of the age is 21. They are all 2020. Because the 2 is the stem.
This is 10.
This is the last digit. So this is 21, 21, 21, 23, 23, 23, 23, 23, 23, 24, 24, 27, 20. Ah, is it me that is doing it?
No.
He's following you.
No, don't follow it. If you follow it weekly, don't follow it. I'm just so that is just it. For this second one, there are 20 of them. 30, 30, 31, 34, 34, 34, 33, 34, 35, 35, 35, 36. They're like that. That's what it means. Look at only this one. The last one is 1. 7. Only 71. Can you say 71? The age is 71. Here there are 9. 60, 60, 61, 62, 63, 64, 64, 65, 65. That's just it. Does it make sense now? You understand it now?
Yes.
Yes,
Yes.
sir.
If somebody publish it, you can even extract the data set and go and run the analysis. Now, this one is quartile plot. I explained it yesterday also. You know, what it just does is that, all this is just to test if this data set is normal or not. Exploring the data. The meaning of quartile are the points that divide 4 things into 4 equal parts. Point. You have only 3 points that divide something into 4 equal parts. If you want to divide something into 5 equal parts, that we have only 4 points. Just like if you draw a line now, if you want to divide it to 5 equal parts, it's only 4 lines that will divide it there. That is what we call quintile, when you divide something to 5 equal parts. They use that a lot in earth economics, in social economy, all these economics, because they will say if you read Nigeria's demographic survey, they usually put the income level, the first 20%, the next 20%, the next 20%. They use quintile, 2020, divide into 5 groups. Usually the economists they usually use it. The earth economy uses it a lot, but normally people use quartile, that is 4 equal parts, 25, 25, 25%. So the line that divides the thing into 4 will be 25%, 50%, and 75%. Those are the 4 3 lines. Those are the quartile. So when we say quartile plot, what it does, it divides it into 4. It divides the data inside the computer, the software inside the computer has a data. So that one is the expected value here. Your own data is the horizontal. What it does is that it divides your data into 4. It divides the data of the computer into 4. It tries to plot them. If in a tug of war, if people are pulling rope and all of them, the force are the same on both sides, the thing will stand still in the middle now. It's the same thing. If let's say your own is normally distributed the way their own data set is normally distributed, because each point is where each of them meet. So all these things should be along the diagonal, because this is a diagonal line. All the points should be along the diagonal. Because of some skewness, you see some are outside the diagonal. It's just a pictorial way of showing it is okay. Don't worry. By the time we are going to go back to that our skin lesion some, because that one is well skewed. You see, scroll down, doctor. Scroll down. This one I will go and check what it actually mean. I don't. Maybe it's just mean. It's calculated, because whenever you see something like that, Okay, maybe the difference. I think he's looking at the difference. Because normally, if yes, I think he's looking at the difference. Because if your own is normally this way, you're supposed to have the difference should be 0. Just go that way, but I will go and check what it actually means. I will explain it because I don't actually know. Look at this one. This is box and whisker. This box and whisker, what it does also is this box, the middle of the box, the line in the middle is the median. That's the 50 percentile. That's second quartile. The lower part of the box is the 25th percentile. That's 25%, which is the first quartile. Then the upper one is 75 percentile, which is the third quartile. The lower end of the whisker, this is the whisker, the 2 whisker, is the minimum. The upper end is the maximum. If you have extreme outlier, it will show it. Maybe when we get the skin lesion, you'll see. Okay. You see that this thing is skewed now. Wait. You see that if it's not skewed, the median should be in the middle of the box. Because we know that it's skewed to the right. If it's skewed to the left now, the lower part will be more than the upper part. There is skewed to the right. That is upper part. On the right, no upper part. If you applaud the upper part, so it's skewed to the right. That's why the upper part is more. If let's say it's skewed to the left, the lower part will be more. If it's normally this way, it's not skewed, the deal will be in the middle. If let's say there are some outlier now, if you put it as dot, you see. Scroll down. So this one is for the weight. You know, that one was skewed to the left, even though the skewness is not significant. But if you can see now, the flatness is on the left side. Just scroll down and see the same shape of the. Can you see the same shape of the? Look at it, of the stem and leaf. So scroll down. What are you looking for? Scroll down. This is the quarter. Just slow down. Can you see the one I assume? Can you see the skew to the left? That's the one that is out of the line. Yeah, scroll down. Go to. Can you see? You can see that the thing is in the middle, but it still appears small. That the lower one is a little bit smaller, bigger, because it's still to the left. Though the skewness is normal. That's how to explore. Now, I want you to stop. Okay, let's. Okay.
Yes, sir.
Yes.
Okay, I wanted to ask, were you able to explain that curve? You know that line that you were saying that you couldn't understand? The one that
No, I will
has
explain later. I was just suggesting. I have not gotten any part about it.
Okay.
I have not got any. I want to. Okay, go back, please. Share again, Doctor. This year, I want us to explore only height. I want to show some height, the height, because the height alone.
The other question I had was that line. You know that line that has like a straight line, then the dot. I know the line signifies when it is normally distributed. Then the dot is the. The line is the expected.
Okay. Share the output for us, Doctor. Share the output, Doctor. Showade, share the output. Is it this one you are talking of? It's okay.
Yes, sir. This one. Yes.
I've explained it now. This is if it's normally distributed, you expect everything to line up.
Exactly. Yes.
That's all I'm saying.
But if it is not, okay. I just wanted to
if you look at this one, it's normally it's only just small skewness, and that is those. Can you see 1 and 2 that are completely off the line?
Sir.
All of them they are on the line, even though all of them are on the line. It's only these 2 that are off the line, and they are lower value. That's why it's negative skew small. If you go up to the other one, the age, where you have a lot of one that are skew, especially positive skew, you see. Go up. Can you see? Can you see? Can you see a
Yes,
lot of
sir.
them up the line here,
Yeah, of the
especially at the
line.
upper part. So, but even we have one up the line here, but it is more on the upper part. That's why eventually it's now skewed to the right. Okay, I want you to, Dr. Showade, go to analyze. I want us to explore only the height. I want to show something. Go to analyze. Why did you will have? Why did you share? I say it's the same data now. Why did you stop sharing? It's there now. Yes. You don't need, you can even go to analyze even in viewer result view. No problem. Just go to analyze now. Don't worry. Just go to analyze now. Descriptive. Go back to that explore. Yeah. Now return that weight and height. Okay, move height. Yes, move height. Move height inside. Okay. Click OK. No, all those things they are there. All those operations they are already there. You know the last thing you did, they are already ticked there. Share the result. That's why I don't move from the result. Okay, let's see. Is this one skew? 1.745. The median 175. Can you see? Is the mean is slightly smaller than the median, but I don't think it's much. Go down. You know it's height now. And you know the height, the value are normally small. So close. So can you see? It's not. Can you see? Look at the test of
normality.
It's not significant. It's almost significant with Shapiro, but it's not significant still. Go on. So we can say that it's normally distributed. Go on. Okay. This is what I want. Where I'm going. You know, I told you why I want to is because of when I was explaining stem and leaf. Is the last digit that is the leaf. The first set of digits will be the stem. In this case, now there are 3 digits for height. You know, it's maybe 1.7, 1.6, 4, 1. So look at the digit, or even if they measure it enter it in centimeter, it's 3 digits. So you see now, can you see? The stem are 2 digits, while the leaf is 1 digit. If let's say the figure here are 4 digits, the stem will be 3 digits, and the last one will be the leaf. I just want to emphasize that. Another thing I want you to do, go back to that analyze. I want you to do something also. Go back to that explore. Yes.
So just so that means the first one in this stem and leaf now that is like 4. How will you say it? Will it not be 4 points?
Hold on, Dr. Showani.
Before there is the frequency.
Sorry, the frequency. I mean. So will it not be 1? Yes, will it not be 1.6? So you know the way you call it out.
Yes. Because now look at it. This 4 now will be 1.60, 1.60, 1.60, 1.6 this thing. Or if it's in centimeter, they measure it 160, 160, 161, 162.
Okay, thank you, sir.
Okay, let's continue. Okay, go to analyze again. Go to that explore. I still want to do something. Explore. Wait. Click under factor. Move a variable. Move group. Move group. Click on that group and move it under pastor list. Okay. Click OK. You will see what will happen. So scroll down to the result down. What did he do for you? What did you notice? Right from
urban and rural.
Thank you, Obara. Yes, you now split it. You explore it group by group. No, we explore all of them together. If you want to explore it by the group, so you don't even need to go and split. You get the picture now. You can explore without even going to split. You get the picture now. So you just put under the factor. Under the factor, you put the group variable. So it will explore it by group for you. I don't know. Scroll down, and let's see everything. Are you with us? Are you tired?
No,
sir.
you.
Can you see both group? They are not significant also. Can you see both group? Go on. Scroll down. Let's just have a, now the sample size is small now for each of them, 35. So that's one of the things that will make it not to even look normal, even though it's normally distributed, it will not appear to be normally distributed because the sample size is very. Can you see almost perfectly? Can you see this one for rural? Can you see? Can you see height for rural? Can you see almost perfectly normally distributed? And you see it even from the statistic also. That one, it's not significant. The something is not significant. Go up to that Chaplowitz test. You see that the rural is more normally distributed than urban. The rural is more normally distributed than urban. Can you see? It's okay. Can you see? Because this urban here is almost significant, as if it's skewed, almost. Whereas this one is not significant. That shows that the rural is more normally distributed. The little skewness you see is in the urban. Okay, that just. I think you can stop sharing. Let's relieve you for a while. Yes. Do you have question on what we have done? Do you have question on what we have done? Nobody is answering me.
No, sir. Come on.
Dr. Briggs. Dr. Briggs, Dr. Judith. Where is Dr. Judith?
Oh,
Oh, she has gone.
I'm here.
I'm okay, Dr. Delapo.
Okay. Everything is okay, right?
Yeah.
So,
Okay. Dr. Judith, hope you are not lost.
no, I'm not.
That's great.
Today I'm calling.
Yes. Don't worry, even the other one you missed, they are just small things. Even those though Dr. Brick is not completely new in this business. So it just, I discovered that those people that know, they want to know more. And that's what the Holy Book says. Say those that know more, they will give more will be given to them. Even the people that don't have, even the one they have, will be taken away. So you discover that people that know, they want to know more. People that are ignorant, they want to remain ignorant completely. So it's just like his principle like that. You discover that most of the people that are here, I was so surprised. Like Professor Etokiden, when he even send money, I say, well, Prof, what are you coming to do? Look at Dr. Abasi. We did this thing in Bayelsa. People want to get to know more. Dr. Anaku, we did it in Enugu. Dr. Briggs also, we did it in Port Harcourt. But the same set of people, they say they want to get to know them more. Oh, Dr. Lagudo, you're welcome, ma. Our able.
Thank you, sir.
What can I call you now? Are you you are the VC or provost? Able provost. God bless you, ma. So let's.
No, sir, I'm a chief student.
Oh, I don't think so. So what I just want to show here is that is gradual. So I don't want Dr. Judy to be discouraged. If let's say you are here, that was how Jowade wanted to be. He was discouraged. Was it yesterday or it was discouraged? But I now told the story that all these people you are seeing here, Dr. Bagawa Ghana, Bako, who click on this. You think he's a novice he's not a novice in the business. So don't let them intimidate you, because you look as if these people are they smarter than me. They got it, I didn't get it. So it's not just one day. So it's gradual.
yes,
People are to appreciate it. And when we have other opportunity, I'll let you know. The last time Dr. Aisha Bello was having problem with her connection, as if so this time, I was so surprised when he just said the first, I said somebody should share. She shared. She just, I didn't even ask her to share. She quickly shared. No, you just came in and, those are the things. You keep on appreciating it every day. So I think we move further now. I want Dr. Bako to share that. Can you hear me? Okay.
Yes,
Dr.
I
Bako,
can hear
share
you.
the
We can hear you. We
screen
can hear you.
share the skin lesion. I want us to
Right, sir.
want to do transformation. We want to do the same. You do the same exploration. We want to do log transformation. You see the way it is. How to do the log transformation.
So you have to allow sharing, sir.
Oh, sorry. I should make you.
Yes, sir.
In fact, I'm not even the hostness. Let me.
I've returned your host.
Okay.
I've returned
Okay.
it.
Let me even. Okay, it has allowed me to even. I've allowed you now.
All
Thank you
right.
for
Good.
returning my host. Some people, when you give them power, they don't return it to.
Oh, see, shit. There we go there. Where's skillation?
Okay.
Skillation. Oh. Let me get to skillation
Okay.
upon data.
I think you have saved it as
Oh,
SPSS today. If it's we can
yes,
open the
SPSS
yes.
lessons.
If it's already here, just show us so that we quickly.
Yeah.
Yes, that's great.
Yes, great. No, this one is.
This is
Let me
by
find it. What did I do? Let me check
no,
it.
it should be there.
Yeah.
You have not. You have to. You know what? Go back to that your BMI and go and open. Go and look for it. Yes, you can now open now. Go and open under file.
Yes.
And look for it.
Under file?
Yes. Now under file, open data. Click on data. So look at the click. But this is skipping. It's skipping. Yes,
sir.
you have seen it. Yes, you have seen it. Now, are we together, please? One house. Let's go to explore. Want to quickly, we will not waste time. Explore that age and go and transform. You see the way the shape is and go and transform. Go to explore, frequency explore. Just explore the age alone.
Age.
Yes.
Age.
Plot. Go to plot.
We just okay.
Plot.
Just went
No,
straight.
okay, no problem. Yours okay. Let's see. You know, you cannot share. You will not see the history. You didn't click on histogram. So the stem and leaf you will see. Scroll up. You see the stem and leaf. You didn't click.
Do it again.
By default, the histogram is not clicked. It's stem and leaf that is clicked. That's not the something you are clicking. Plot. Yeah. Can you see now? By default, stem and leaf is here, but the histogram now. Then normality plot. Okay.
Yeah.
Continue now. Okay. Okay. Okay, scroll up. Let's see the. Yes, it's okay. We don't want to waste time. This is okay. Look at the shape. Look at the shape of histogram now. So where is this skew to?
Right.
Skills to the right.
It's still to the right. Thank you. So let's go. One of the things you can do if something is skewed is to transform it. When you transform it, it makes it look better.
Okay.
Okay, I want to do something because whenever people come for workshop, I want you to get value for your time and your money, right? You don't just rushing marking something. Stop sharing. I want to share. I want to share something. We'll come back to you, Doctor. Yes, I want to share something.
Right, sir.
Yeah. So look at, let's say we have a set of number, let's say X. These are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we now decide to say we want to square X. What's the value when you square S?
1. 4,
4,
9,
9,
16,
16,
25,
25, 36, 49,
49,
49, 64,
64,
81, and 100. Yeah.
Okay, let's find let's find the square root of them of the x. So square root of x.
Okay.
One
One.
is 1.414,
1 point something.
something like that. If you remember root 2 in your
Mm,
mathematics, this is
mm,
1.372, something like that. If you remember root 3. So this is
yes.
2, right?
2,
This
yeah,
is
that's
this
2.
will be 2 point something, right?
2 point,
Yeah,
This
2
will be
point
2
something.
point something also. This will be 2
Yes.
point something also. This will be 2 point something also. And this will be
Almost 3.
3.
3.
3,
And this will be 3 point something, right?
3
Now,
3 point
points. That's
something.
right.
yes.
Yeah.
3 point
So
something.
what
Yes.
I want us to see is that when you square these numbers are the gap between original number is 111 because just 1 to 10 serially. When you square, it increases the gap between them. Can you see? It
Yes.
decreases. Look at it. When you square, look at this one. The difference between this one and
Yeah.
1 it become 3 here. This one, the
3.
difference is 5.
Yeah.
And the difference
5.
here is between 9 and 16 is 7.
7.
The difference here
8,
is 9. The difference here is
7,
11.
Mm,
There is 13.
mm,
The difference is 15.
mm,
Can you see now? The difference between
That's
as
true.
you
That's
square, the difference between two. So what square does is
increases.
squaring something blow off the figure. Now, when you find the square root, it shrinks the distance between them. Can you see? The distance between them is
Yes.
now less than 1. Can you see?
That's right. That's right.
So can you see
That's right.
transformation now? This is a form of transformation now. This first one is
That's
square
right.
transformation. The second one is square root transformation. Right?
That's right.
Now,
That's right.
I want to show you another thing. Let me just share one slide with you to explain this issue of somebody sent chat. So consider the time. It's over an hour now from the last time. So, though this woman, you are very wonderful. You have a good timekeeper. I'm following the very okay. So I don't know now. Should we continue or should I log out? Because if we continue like this, the thing will be too heavy to share with you. It will not. It's going to be difficult. Even if I upload it for you to download it, the volume will be too much for you.
Let's log out now.
Let me log out and we log in so that we can. I don't know how we can. I don't know that technology. If there's a way you can just save this one and continue. I don't know if anybody knows. So what day you know it? You know how to save and continue? You don't know. You don't know, right? Okay, let me log out. If I leave, what if I leave? No, it will not help anything.
It will not work.
It will not end the meeting. Yes, I want to end the meeting so that I can save it.
It will work.
Eh? Who says somebody said something?
Yes.
No.
If you leave alone, it will still continuous because we
Yeah.
are still going
Exactly,
on.
yes.
Exactly.
I want to
If we
abort
just
it so
change
that I can
the
save that one separately and we start new one, new video.
yeah.